Today I'm going to explain why your C++ code is slow. So, let's say we have been creating a 2D game engine or a 2D game, and we're going to create a game object. And then I could say, alright, well, I can declare my fields here. So I have double shoot speed, and then I can add bool is active, and then I could also add a couple more fields like float, health, and then maybe char, maybe in between here, I just add char, whatever, and then I can just do whatever I want, correct? Here is a C++ struct, but you may think that, this is good code. So as you can see, we have our health, and then just to put it out there, let's put an std vector inside of here. As you can see, we have our game object here, and then let's add a std, let's add a name, and then let's say I add a name. Now, as you can see, here's our game object. We can use it as normally. We can use it normally. We can do whatever we want with it. But the problem is, if you hover over it, as you can see, the alignment is 88 bytes. The size is 88 bytes. However, the alignment is 8 bytes. So we could use this normally, but this struct is misaligned in memory. Now let me explain why. So memory misalignment stands for the way that object and data is structured in memory. Now, in C++, this is a low-level language, so the CPU wants to read memory in a specific way where it doesn't have to fetch more memory with multiple clock cycles, so it can just grab your next value or whatever in two grabs. So say for an example, so this struct has something hidden underneath it, and that is called padding. Padding are extra bytes of just hidden bytes so that the CPU could see this and then go through and efficiently grab all of your variables without having to worry about this misaligned memory. As you can see, C++ handles this for you. So you're allowed to do this. This is allowed in C++. You're allowed to create misaligned memory or aligned memory, but I'm going to show you the correct way to align your memory and align your structs. So this is a bad game object. Now I'm going to explain why. So if we try to use the size of function on bad game object and print the size of it, and then we run this, as you can see, we get 88 bytes. So we know that there are bytes of padding between here. Now, to make sure that we are, following, memory alignment, we need to know the size of our types. And as you can see, here is the size of most basic types we use in the C++ programming language. So we have a Boolean, which is 1 byte, char, 1 byte, short, 2 bytes, integer is 4 bytes in memory, and then we have a long, which is either 4 or 8 bytes. So large integers at least 32 bits. We have a long, so at least 64 bits. This is 8 bytes. We have float, which is 4 bytes, and then double, which is 8 bytes, and then we have long double, and then pretty much any other types. So by looking at the size of our types, well, we need to make sure that our structure is perfectly aligned in memory so that the CPU doesn't have to go through and grab more memory addresses or grab more bytes, so it has to read your whole struct. It has to say, oh, okay, well, look, it has double here, and then there's some bytes of padding in between here so we can get this, and then there's some bytes of padding in between here so we can get this. Now you understand that this, if our struct is aligned correctly, and it is multiples of its the struct address is the largest multiple of the largest item in here of the size, then that is a good idea because this could hit the CPU cache lines and this could give us the best performance ever in our app. So here is how we fix bad padding, and here is actually how we properly align our structures in C++. So this is the bad game object, and remember, the CPU wants the address of the struct to be the largest multiple of the item in here. So the largest item in here needs to be divisible. The address needs to be divisible by the largest item in here. I'm not really good at explaining the internals, but just know that your structs should be aligned properly so that the CPU could hit the cache and grab this object within one whole grab instead of using multiple clock cycles. So let's go ahead and recreate this bad game object, shall we? The first thing we do is, well, we're just going to create another struct called good game object. Then, depending on our variable size, we can sort each item from largest to smallest in size. And as you can see, we could just hover over here and see that, okay, well, this is 32 bytes, this is 40 bytes. We can hover over and see the float. It doesn't tell us, but we know that a float is larger than a bool or a char. And then we also know that a double is larger than a float. So here is how we actually properly align our struct. So we're going to add std string name first because it is larger than the vector, and then std vector, std string, list, and then after that we're going to add our double, shoot speed, and then we can also add the float health, and then the last but not least we can add a char because that is 1 byte, so we could say char whatever. And this is a properly aligned and padded struct. As you can see, they're both 88 bytes. They're technically 88 bytes, but if I shifted this around or somewhere else, if I made this into, if I added more bigger types or bigger objects, then I'll try to actually misalign it. But as you can see, this is a properly aligned struct. As you can see here, I'm going to pass in good game object. And then I'm going to run this program. And as you can see, well, they're both 88 bytes. So let's try to create an unpadded struct just so I could show you. So let's say struct unpadded struct. And then I'm going to add a char a int I double c float b std vector. And then let's do double numbers. And then let's add, for the fun of it, let's add another vector std string names list. Okay, now this is still 88 bytes. So let me see, instead of large, let's do like after the double, I'm gonna put it here. This still says 88 bytes, so size of unpadded struct. Alright, so then let's add the numbers after the integer. Let's add more fields. So char I int, let's just try this. We're going to add more random stuff until our struct grows in size. And I'm going to show you how to properly align it. So let's do std string key, std string value, maybe another string message, and then we're going to add these before the float, after the float actually. That takes up 216 bytes. Look how much memory we're wasting just by the compiler having to add padding all between these. Alright, let's purposely make this large. So we're going to do vector, and then let's do int some other numbers. and then and then let's add yeah, I'm gonna add that after that, but what about, let's do, instead of biggest to smallest, I'm gonna declare the string before that called cool, and look at that. Look how much bytes we have wasted. 288 bytes. That is large. Now, as you can see, it's giving us errors because it's in different basic types, so I don't know what it's saying. But I'm adding as much fields as I can, and it just doesn't want to. Oh, I redefined something. So there's two i's here. I'm gonna do IC, and I'm gonna run this again. All right. So as you can see, that's 288 bytes. Now we can do better on this. So as you can see, let's say we were creating some C++ program and it was using lots of unpadded structs. I'm saying, what if we did this? std vector and then unpadded struct and then hello world. We're going to initialize it like that. We're going to say hello world reserve 1000. This is just going to waste a whole bunch of bytes, bro. At this point, it doesn't even matter. And then what we're going to do is we're going to say for size t iter equals 0, iter hello world size, iter plus plus. We're going to say, well, I don't really want to push too much vector items, but just know that if I have like 1,000 items in here, it's just going to waste a whole lot of memory. But let's say I wanted to do this as well. I want to do unpadded struct, raw buffer, actually buffer equals hello world data. This gives us the raw pointer, and this returns unpadded struct. It says, so there's this, oh, it's a pointer, so it should be a buffer. So there we go. Now this is misaligned as well, because since this is misaligned, then the CPU has to go through this padded buffer with the extra wasted bytes, and it has to go multiple clock cycles just to grab your variables in here, which is not ideal for performance, cache, and scalability for your app. So to reduce memory usage, you have to correctly pad your structs. And to do this, let's go ahead and create a struct called padded struct. And this is the correct way to pad this whole thing. So we need the largest item in here. And I know that this one is 32 bytes. The string in here should be the largest item since it's all 40 bytes. So let's do this first. We're going to do std string. And then let's just do cool. We're going to add another item. We're going to add value. Message, and then, okay, so we have those already, so we can cross these off the list. So we have cool, value, message, and then now we need to get the other things that are large as well. This one's 32 bytes, this is 32 bytes as well. So if these are 40, if these are all 40 bytes, as you see, look, we're already at 120 bytes. So like we reduced all that extra bytes down just by correctly padding our structs. We see that we could add either this one or we could add this one as well. So let's do name list and then we're going to add some other numbers. Vector, std string, name list, std vector, int, some other numbers. Okay, so we have pretty much everything here. Now it's just between these values here. Now I know that a double is larger than a float. It's larger than an int, and it's also larger than a char. So that double is going to go here. So this is going to be double, and then we're going to add c, and then we're going to then also add float because it is larger than a char and is also larger than an int. So we're just going to do float, and then we're going to add b. And then the next thing we know that an integer is larger than a char, so we're just going to do int world, and then we're going to also add char a and then char IC. Now, as you can see, if we hover over the padded struct, it's 208 bytes, but this one's 288 bytes. See, we chopped off nearly almost, I would say 80 minus 8, so we chopped off 80 bytes. Since it's 88, we chopped off 80 bytes of padding, and this struct is padded correctly. The struct is aligned and padded correctly, which means 208 should be a multiple of the largest member in here, so the CPU could go ahead and grab everything in one clock cycle. So as you can see, this shouldn't be misaligned anymore, and the C++ code should hit the cache lines and become faster. Now that is really padding in C++, but the last thing I'm going to do is I'm going to output the size of the variable, and I'm just going to do size of padded struct, and then print it out. As you can see, we have 208 bytes. So we've reduced memory usage by somewhat a lot. I'm not really sure if this is padded correctly, but if you want to enforce padding, you can also use the align as keyword, and you can tell it, hey, I want to align this as 8-bit alignment, or I want to align this as 16 alignment, or I want to align this as 32 alignment. You have to, you can, using align as will also help you here as well. So I prefer the other way where I just align it from largest members to smallest members. This will ensure that your CPU, this will ensure that your application hits the cache lines, data moves fast, and you don't deal with performance issues because your code is faster.